Question number 2 asks, which of these are factors? If there's going to be a factor, if they're going to be factors, the factor theorem says the remainder needs to be 0. How do we find a remainder? We could find a remainder either with the remainder theorem or with synthetic division. So the first one, this would be the only one of these 4 where I would say remainder theorem and synthetic division are about equal. So the remainder theorem, you'd have to plug in -1. And that's not hard to do. -1 cubed minus 6 times -1 squared is 5 times -1 plus 12. Probably some of you wouldn't even write that line. You would just do mental math and go -1 cubed is -1. -1 squared is 1 times the -6 is -6. -1 times 5 is -5 plus 12. I get a remainder of 0. So I know that x plus 1 is a factor. Could we have done this with synthetic division? Absolutely. Synthetic division would say 1, -6, 5, 12. On the outside, I put -1. Bring the 1 down. Multiply, add. Multiply, add. Multiply, add. I get a remainder of 0 that way as well. Oh, I would lose a half a mark on this question. See how I wrote p of -1? Is there a p anywhere in this question? No. So the very first thing I would do is I would go above this and say let p of x equal. They have an error in grade 12 pre-calculus. If you're using a variable that's not introduced, you'll lose a half a mark. So you have to introduce, like, I'm going to use the letter P in this question. I need to tell you where that comes from. So I define it by saying let P of x equal this. Then I'm allowed to use P of x all the way through. This also tells me, here, I'll just erase this one. This also tells me I can write the division statement. This is why synthetic division is nice. To be x plus 1 times by x squared minus 7x plus 12. Now I want you to leave a little bit of space there, and then we'll go to B. Whew, another half mark off. Not closing my bracket. Part B says divide by x minus 3. Now that 3 is bigger than 1. This makes the most sense to do your synthetic division. X minus 3 would be a plus 3 out here. We'd have 1, -6, 5, and 12. Bring down the 1. 3, add, multiply -9, add, multiply -12, 0. We got another remainder of 0, so we have found another factor. And if I wrote the division statement for this one, I would get P of x equals x minus 3 times by x squared minus 3x minus 4. I'd like you to leave a little space under this. I'll go to part C. In part C, it says, is x minus 4 a factor? So again, 4 is a big number. It's not that big, but for these questions, if you're using the remainder theorem, it would be big. steal the numbers there, we have 1, negative 6, 5, 12. X minus 4 would put a positive 4 out there. Bring the 1 down. Multiply. Add. Multiply. Add. Multiply. Look at this. Are they all going to be factors? And if this is what we did, then we could write this division statement. P of x equals x minus 4 multiplied by x squared minus 2x minus 3. Leave a little space under that one, and then we'll get to D. And we're dividing by x plus 4, so this will be a minus 4 out in front. Bring down the 1, multiply, add, multiply, add, multiply, and add negative 108. So finally, we get one that is not a factor. When you factored in x squared, you got 2 factors. When you have an x cubed, like we had originally, what do you think the most number of factors you could get? 3. Did we find 3 factors? So we can't, I'm not going to write a division statement for this one, but you would know that the 3 factors we found, one of them was x plus 1, one of them was x minus 3, one of them was x minus 4. And the reason, something really neat about this, is all of the first ones multiplied together will work out to be x cubed. And all of your last ones multiplied together will give you your last number plus 12. And if you did all of the other arrows that are possible, you would get all of the other stuff in the middle. So there's not a FOIL, because there'd be like FOIL, because there's a lot of extra stuff happening in the outsides and insides. So it would be hard to come up with an acronym to describe the multiplication here. But you still have your first and you still have your last ones. And what I wanted you to leave a space for is if we go back up to the very first one. The very first one, we got the x plus 1. Do you notice that you were left with a trinomial? If you wanted to, could you factor this? Well, it would have to be x and x. To get 12 and make your outside and inside be 7, you see it would have to be minus 4 and minus 3. And there's our 3 factors from this one. We scroll down to the second one. The second one, you found x minus 3 already. It left you with this, which is a trinomial. And you would have x and x. To get 4 would be 4 and 1. The 4 would have to be negative. The 1 would have to be positive. The same answers, same factors as the first one. Just you found the x minus 3 first. Or if we look at the last one, or the x minus 4 one, we found the x minus 4 first. This is a trinomial. If we could factor it, it's going to be 3 and 1, minus 3 and plus 1, and we get the same factors again. So when we get to the place where it says factor completely, and that's where we're going, you're going to get a polynomial like this p of x we had to start with, and it says, can you factor this completely? What you're going to need to do is you're going to need to find one of them that works. Once you find one of them that works, you can write your division statement. So let's say you tried -1 and it worked. You tried it either with your remainder theorem or with your synthetic division. Once you find out one that works, you can write the division statement, and as soon as you get to an x squared, you can factor it like you normally do. And this would be factored completely. Okay? Now, notice the factors that worked were x plus 1, x minus 3, and x minus 4. And we were able to factor it because they gave us this and we found out all three. Okay? But let's say they didn't give you these ones to try. Why would trying x plus 5 be a bad idea? Like for sure, x plus 5 is not going to work. Why is x plus 5 a bad choice? And the hint is at the bottom. Why would x plus 7 be a bad choice? But x plus 6, not too bad. X plus 6 doesn't work, but it's not a bad choice. But x plus 7 is a bad choice. X plus 5 is a bad choice. I'm trying to find one factor. The hint is in the answer here. If you think about okay, what do we notice about the last ones? They multiplied to give us 12. Can you see 5 would be a bad choice? Because 5 times what is 12? Oh, it doesn't work out nicely. 7 doesn't work out nicely. 6 wouldn't be bad, because it could be 6, 2, and 1. I could have one where that works. But we're always going to have this last one work out. And this is what it says at the bottom of your page. So if we look at the bottom of the page, at the factor property, that the factor has to divide that constant term.